Hello viewers, today we are going to see biodegradable polymers PLA, that is in the series of smart materials. This is Dr. S. Rekha, Associate Professor, currently working in RMK Engineering College, Chennai. Polylactic acid is a biopolymer which is prepared from naturally occurring lactic acid. What is a biopolymer? Biopolymer is a polymer which is prepared from a naturally occurring monomer. So this is lactic acid is naturally occurring substance from which biopolymer is prepared. So it is a thermoplast and it has a very good mechanical property and also high biocompatibility, and most importantly it is a biodegradable polymer. Lactic acid monomer is 100% renewable resources. It is taken from corn, sugar beet. Okay, so PLA can be produced and used in environmentally friendly cycle. Okay, so PLA is renewable natural resource that is commercially compostable in just 75 days and requires 30% less energy and 50% less carbon dioxide to produce than conventional plastic. So carbon footprint is also less for this substance. How it is produced? So you can take either of the substance. Okay, so by photosynthesis you have corn, tapioca product, sugar cane, anything you can take. From that you extract, you get starch, and enzyme hydrolysis it turns out dextrose, then fermentation it gives you lactic acid. So using lactic acid as a monomer we can prepare the polymer. So how polymer is prepared now? So polylactic acid which undergoes polycondensation, okay, in the presence of catalysis to form PLA. So it is a direct chain formation with the liberation of water. That is byproduct is H2O. There is another form of preparing where we have a lactide which is a ring. Okay, so ring opening polymerization with catalyst. So here the starting material is lactide and it gives you polylactide, so that is PLA. Okay, so you can prepare either of the method. Then properties of polylactic acids. So it is a linear polymer and it is thermoplast in nature, so it is recyclable. So it is having 37% of crystalline in nature. The glass transition temperature is 50 to 80 degrees Celsius. Melting point is 70 to 180 degrees Celsius. And it can be processed into fibers. Soluble in chlorinated solvent, dioxane, benzene, THF, all organic solvent, almost it is soluble. And based on its chiral nature, available both in L and D form. It is very important properties. It is biodegradable polymer. Today why we are seeing about polylactic acid is one main important feature is biodegradability. Application of polylactic acid. So it is used in biomedical implantation. You remember that I told it is biocompatible in nature. So it is used in biomedical implantations like plates, pins, rods, screws, everything. So it is used. Okay. Biomedical applications like sutures, okay, dialysis medium, drug delivery devices, etc. Disposable items such as food packaging, compost bags, tableware, cups, etc. Because it is non-toxic also in nature. Okay, so it is used in food packing industry. Used in the preparation of fibers which are used for making disposable garments, hygiene protection, etc. But in the period of corona, a lot of garments, disposable garments were made up of polylactic acid, and it is biodegradable. That is the plus part of it. So other applications you can see food applications, since it is non-toxic, so we can go for food applications. See, tea bags are made up of this PLA. All these materials are made up of PLA. Okay, glass tumbler, water tumbler. Okay, this packaging, food packaging material. We said about the stitches, right? So stitches are made. Okay, all these are made up of this, and in this plastic is there. Stent is made up of nitinol, and in that, whatever the plastic part is there, it is PLA. Okay. And for wound dressing, it is PLA, diapers, PLA, dialysis, the PLA. Thank you, students. Let us meet in yet another smart material. Thank you once again.